All right, guys, here we go with our science notes for what is the scientific method. So if you have not watched the video of Mrs. Preston teaching you, then you need to stop this video and you need to go back into the first video of Mrs. Preston's lesson with what is the scientific method. You don't want to miss it. Then you can come back to this one. But if you've already watched that, you're ready to go. So here we go. We're going to get our notes pages and we're going to do a flip book into our notebook. So make sure you have your science notebook. Make sure you have your science textbook because we're going to use some pages and we're going to highlight some information that'll help you with your independent work today. And then, of course, make sure you have your red science folder so we can pull out our notes pages. Glue stick, pencil, highlighter, scissors, of course, and colored pencils. Make sure you have all your materials handy dandy. And remember, you can pause and rewind this video at any time or rewatch any parts of it that you need. The way it's recorded, you can pause and rewatch. All right, so as I told you, the scientific method is something that scientists use when they want to conduct an experiment, and there's certain steps they must follow. There's lots of scientific methods out there. There isn't just one. But for fifth graders, we're going to learn the main steps to the scientific method to help us conduct a science experiment in which we want to test something. So let's get our notes pages out first. Let's pull out what we're going to need. So open up your red folder. We're going to skip a few pages. So you can just put them at the bottom. So this is probably your next page. We're not going to use that. Then you're going to see what is the scientific method. We're going to use this one today. And actually, we're not going to skip any pages today. And then right behind it, you will see a page that looks like this with a long rectangle and a bunch of little rectangles next to it. We're going to use those two pages today, okay? So these are the two pages you want to take out of your bundle pack. And then you can put the rest away, okay? And stay organized. Go ahead and put your folder away. You won't need that. Whoops, sorry. You're a little dizzy here. Let me get you back. There we go. Bumped it. So these will be the two notes pages that we need for today. Okay? All right, we're going to turn this guy into a flip book, so make sure you pay careful attention. Let's go ahead and cut them both out. Let's get them all ready. So we're going to cut along the outside rectangle. We've got it measured so they'll fit right in your notebooks. Okay, go ahead and get him cut out. Now this guy, for right now, we're just gonna cut around the outside rectangle. That's all we're gonna do for right now, is we're gonna cut him out along the outside rectangle. Do not cut on that dotted line. The dotted line for this guy does not mean cut, and we're gonna use him later. Okay, so this is what we should have out. We've cut him on the outside rectangle. We're going to do our notes from here. But before we do that, make sure you have your notebook and your textbook handy, okay? All right, I'm going to go ahead and zoom in so I'll make you dizzy for a second so that you can see this better. There we go. Okay, so as you just saw when I taught you about the scientific method, and I gave you some questions that scientists might use with an experiment, and that means that they want to test something, okay? And when we test something, it means we have to follow the steps to the scientific method. So we're going to highlight scientific method. That's our big vocabulary word today. And anytime we see method, we're going to think of this word. Steps. Okay, so go ahead and get that on there. Remember, these are your notes page. This is your right side. And what is the scientific method? Well, it is a process that is used to find answers, so we're thinking like a scientist, to questions about the world around us. Okay, so when the scientist wants to find answers to a possible question about the world around you, you're acting like a scientist. And sometimes that means you have to go through an experiment. And if it's an experiment or a testable question, that means you have to test something, you would follow the method. Is there only one scientific method? Hopefully you remember what Mrs. Preston said, and the answer is no. In the world, there are several versions of the scientific method or steps to carry out an experiment. Some versions have more steps, while others only have a few. However, they all begin. So no matter which scientific method you're using as a scientist or what you learn as you go through school, they will all begin with the identification of a question or a problem. And that only makes sense that scientists would come up with a question or a problem first. And they want to come up with a question or a problem that can be answered based on observations of the world around them. And hopefully, you have provided yourself with an organized, if you're a scientist, I'm talking to you like you're a scientist, method for conducting and analyzing an experiment. So let's see, we're going to highlight two words here. Experiment means that it can be tested. Remember, some things that scientists wonder about are just investigations. They just wonder about something. But if they want to test something or see which is better or how many licks does it take to get to the center of a Tootsie Roll Pop, they would test that. How about this word, analyzing? Scientists do a lot of analyzing, and that means they study further. A good scientist isn't just going to stop halfway through. They're going to keep analyzing even after the end of the result of their experiment further. So here's the steps to our method. Scientists always identify the problem, which is sometimes a question. So they identify the problem or ask themselves or other scientists a question, and then they write a hypothesis. You may remember that word from last year. Scientists come up with a hypothesis after they form their problem or their question, and that is an educated guess based on their observation. So a hypothesis is a guess that a scientist makes of what they think will happen. After they form a hypothesis to their problem or question, scientists need to do a little research. So they have to go out and do a little research and make some observations of things. And when we observe, we don't just use our eyes. We use our sense of touch, smell, taste, if possible. So first, a scientist is going to identify the problem. Then they're going to do a little research. Then they're going to form a hypothesis statement. Up here, they're just thinking about what it could be. Okay, and a hypothesis statement is an educated guess based on their observations and their knowledge of the topic. So scientists will state their problem. They'll do a little research. They'll come up with a hypothesis statement of what they think the result could be. And once they do that, they're ready to do the fun part, and that is test your hypothesis by doing an experiment. So scientists can't do the experiment before some other steps. They state their problem as a question. They do a little research on whatever it is that they're experimenting. They form a hypothesis statement of what they think the result could be. Then they're ready to test. And that means they're going to actually do their experiment. Now, while a scientist is doing their experiment, they will be collecting and graphing their data. So scientists, while they're doing their experiment, they will collect and graph their data. And your data is information gathered during an experiment, and you have to gather it during the experiment. So you might be taking tallies of something, or pictures of something, or counting something. That would all be collecting and then maybe putting your data into a graph while you're doing the experiment. Good scientists then will take their data and they will study it. And after they've studied their data, then they might be ready to make a conclusion. Okay? All right, so your steps are problem, research, hypothesis, experiment, collect, graph, study, conclusion. So we're going to write these uppercase letters. Problem, research, hypothesis, experiment, collect, graph, study, and yes, I put them together, our data. Then finally we can make a conclusion. Okay. You have to remember them in order, and you have to remember what they are. Of course, your problem as a scientist is what you're wondering. It's what you want to test. Your research means you go out and you study more about your topic. So if you're doing an experiment on paper towels, you would need to research the brands of paper towels. So research means look up things, investigate on the computer, go ask people and do interviews with other scientists that know about your topic. Then you're ready to form a hypothesis statement, and that means a statement that says to yourself what you think the result's going to be. After you form your hypothesis statement, then you're ready to do your experiment, and that means you actually get to test what it is that your problem is. So you will be conducting an experiment after that. So problem, research, hypothesis, experiment. While you're doing your experiment, you are collecting, graphing, and studying your data. You're doing all that, collecting, graphing, and studying your data while your experiment's going on. And after you collect, graph, and study your data, you're ready to make a conclusion. So PRHECGSC is what we need to remember, and that's a lot to remember. So Ms. Preston's going to teach you a riddle. Promptly run home eating chewy, gooey, soft cookies. If you can remember that riddle, you'll remember the steps to the scientific method in order. Promptly run home eating chewy, gooey, soft cookies. Promptly stands for state my problem. Run stands for do some research. Home stands for my hypothesis statement. Eating stands for do my experiment. Chewy, gooey, soft stands for collect, graph, and study my data. Cookies stands for conclusion. Okay, you're going to go ahead and glue him in to your very next right side. We cannot skip pages in the science notebook. So I'm on my very next right side. I have a left and a right. Very next page, which should come right after your tools page, which you should have number 6 on. This guy's going to go on your right side. So go ahead and glue him down. Okay. You're going to have 2 videos to watch for this notes lesson. This one, in which we're going to get all our information, and then the next video that you'll see is how to make your flip book. Okay? All right, we need to date and number our pages. So number 6 was this page. Number 7 will be my left side. So this will be number 8. And then don't forget to date them. So today's date is September is the 9th month, September 10th, 2020. Okay. All right, keep him open so that you can refer to your notes, but I want you to grab your science textbook now. And I want you to turn to page 27. Now these notes, actually 26, this page. We're not going to read all these pages together. In your assignment, these pages will help you with your flip book. I'm just going to kind of go through and highlight some key information. And then you are welcome to use this textbook to finish your flip book, which you'll learn what to do in the next video. Pages 26 and 27. And then pages 32 through 35 will all help you, 35 is this one, with information you might want to put in your flip book. And it's all pages about the scientific method you are responsible for knowing, the steps. So we're going to highlight and we're going to use our pencil for some things. And I'm just going to pull out some important areas that you can look and use this book for your flip book. So all these pages have to do with the steps to the scientific method, which if you look in your notebook, because I'm looking in my notebook right here that I have, the first step is problem, for promptly. We are going to start with a problem or a question. So let's write problem here. And let's cloud this. Scientists observe the world and then ask questions that are based on their observations, but not all questions are the same. Good scientific question is one that can be answered by investigation. A scientific investigation always begins with a question. That can be known as your problem, and you'll state it as a question. Then it goes into plan an investigation. Once a scientist has a testable question, Ms. Preston said that, testable. It's time to plan an investigation, and scientific methods are ways that scientists perform investigations. There are many ways that scientists investigate the world, but all scientific methods use logic and reasoning. Let's look over here. Some scientists might decide to use experiments. Some might choose to use repeated observations, and some may choose to build a model. All of these are ways to test what it is the scientist wants to test to get results for. Here's a highlighted word that we'll need. Experiment. An experiment, let's cloud it, is an investigation in which all the conditions are controlled. That's kind of confusing, so let me explain that to you. When you have an experiment and all the conditions are controlled, that means you are testing something. You can write that off to the side. You are testing something. When it says you're controlling, you're testing it. And another step to the scientific method is a conclusion. Let's put a cloud around that. You can highlight that word too. Whatever the scientific method is that's being used, scientists will have results that they can use to draw conclusions. Conclusions may answer the question that they asked before they begin. Here's your key word. Not all answers will be given. So you could use these two pages. You could use page 26 and 27 to help you with your flip book. Once in the next video, you see what you're going to do in your flip book. I'm going to start it with you, though. All right, let's flip to page 32. I'll skip a few pages. All right, this kind of puts your steps in order. So when you're reading this section, you're going to learn a lot more about what it means for a scientist to ask questions. You know a freezer is cold enough to freeze water. You also know that juice is mostly water. You ask, does adding substances to water affect its freezing point? Let's highlight that, because that would be a tested, or we're going to call it a testable question. That means the scientist would have to use the scientific method to get their answers possibly. Many science questions, including this one, can be answered by doing an experiment. And an experiment is a procedure used to test a hypothesis. There's a keyword for you. That's part of your method. It's a good idea to make some observations before stating hypothesis. For example, you might pull out a small amount of orange juice in the freezer and then you check it every few minutes to look for changes. So you always start with a problem or a question. Let's write that word problem again. And scientists state their problems as a question. All right, this section you'll learn more to use possibly in your flip book about what a hypothesis statement is. So you've stated the problem, you've done a little research, now you're ready to form a hypothesis. And a hypothesis is a statement that can be tested and will explain what can happen in an investigation. What can happen. That doesn't mean it's what's going to happen. It's what the scientists think can happen. So you want to make sure you read this section to help you with your flip book too. And then a scientist will be ready to do their experiment. And an experiment has 2 or more setups. It allows you to compare results among them. For freezing or melting an experience, each setup will be a cup of a liquid. And it will have variables. We don't need to worry about variables too much right yet, but it's coming. That just means it's anything in the experiment that can be changed. Okay, so in this section, you might find some more information to help you understand better what an experiment part is to the method. That just means you're going to actually do it. That's the fun part. So you've asked a problem, you've done some research, you've formed a hypothesis statement, you're doing the experiment. And while you're doing the experiment, go ahead and turn the page. This also goes with experiments. So let's cloud. This also goes with, let's see, where can we squeeze it? I'll put it here. That's your experiment step. So that will help you. But while you're doing your experiment, you're going to be collecting, graph, and study. That's what analyze means, study your data. So what does that mean? That means that a scientist might make a chart. They're collecting, they might make a tally chart, they might take pictures. Then they might need to make a graph to show which one has more, which one has less, whatever they're testing. And they gotta study it with other scientists. Because once you collect, graph, and study, as a scientist, you might be able to come up with, well, you will, whether it's what you thought or not, your conclusion. And scientists make conclusions based on their results. And big word for science, we have to use evidence. Okay, remember, if I went a little fast for you, because I probably did because I don't have anybody in the room with me. We started on page 26 and took some notes of sections you're going to want to read when you do your flip book today. So if you need to rewatch this video or pause it, you may. And we looked at 27 and I pointed out some sections that will help you with your flip book while you're working independently. And then we turned to page 32. And that was where our steps were. Problem. Research was skipped in this book, but it's not going to be skipped in our flip book. Hypothesis. Doing your experiment. This also was your experiment step. Collect, graph, and study. And drawing conclusions. Now, I went through these pages and found sections that are good for you to read. Your job is to go back and read the sections because they'll help you with your flip book while you're doing it. Okay, go ahead into the next video and we will start making our flip book to show the steps to the scientific method. Keep this book out though.